Okay, welcome everybody to the last session for today. Okay, thank you for holding on. In the next 30 minutes, I'm going to talk a little bit about JMX and Jolokia. Before I start, some words about myself. I'm a Java developer, maybe since 20 years, and work in Munich at a company called Console. It's a mid-sized company. And what I'm doing and what I'm talking today about is open source stuff. I'm the developer of Jolokia. This is the topic for today, but I also do some other things like JMX for Perl. This was a predecessor of Jolokia. And the newest kid on the block is a Docker Maven plugin. This is also why I have this shirt. So if you have some questions about integrating Docker builds with Maven in your build, we can talk later. I'm here at the conference the whole week. And finally, I'm doing also growing chili pepper. This is important here because you might wonder where this name Jolokia comes from. It's one of the hottest chili types. And so if you have also questions about growing chilies, you can help you maybe also. Okay, but that's enough now. So JMX, I think every Java developer who is in the field for some time has met JMX in the one way or the other, because JMX itself is a very old technology. It originates maybe even from the last millennium. And as you can see from the JSR number, it's quite an old one. It's one of the first, and it's all about management and monitoring. So JMX, the management, Java management extensions, are about management configuration, which means that you can change configuration values, but also about lifecycle operations like starting things or stopping things and so forth, like doing garbage collections. And the other big part which JMX covers is monitoring, like monitoring your memory, heap memory size, or the size or utilization of your database connection pools. This is all things which you can query with JMX. As I said, JMX is quite old, and and although its API is a little bit rusty, maybe it's, in my opinion, one very well-crafted API, and it has survived all the years. And the good thing is that it's available in every JVM out there. Since Java 1.5, you can be sure that JMX is there, and there are a lot of metrics which you can directly use. So I have seen in the speaker list that Eamon McManus is here. I don't know whether it's in the room. I don't see anything. Okay. Hi, Eamon. So he's really the father of JMX. So he's one of was the spec lead for a long time, and so maybe. And I thank you for this very nice API. I really appreciate it. But I'm not here only to praise JMX, but because there's, in my opinion, one dark spot in the JMX, and this is remote JMX. So the way how one can access JMX remotely. And I'll tell you why. So one of the biggest problems of JMX, and this is also the reason why I've done all this open source stuff, is that JSR 160 is Java only. So if you want to access JMX remotely, you can do this only within Java client. And this is an issue for monitoring systems which are not written in Java. There are a large number of them. One prominent one is Nagios, for example, which is written in C. And if you want to use JMX for monitoring with Nagios, what you have to do is to start a JVM, measure one matrix, and then shut down the JVM. And this you have to do for every matrix if you make it normally. And if you have a lot of Java servers, then this is of course a lot of overhead. Another pain point of JSR 160 is that crossing firewall boundaries is really hard. This is the reason lies in the network protocol. It's RMI, and if you know RMI, it's something which has a little bit of handshake at the beginning, and then the client and the server settle down of some ports. So it's not a fixed port from the very beginning, and you have to open up a whole port range for your firewall if you want to access JMX via RMI. This is not something your sysadmin is usually keen on. And another part is that security is, if you do it in the easy way, normally it's all or nothing. You can secure JMX communication with user and password. But then if you are in JMX, then normally you can do everything. You can restrict this with Java security, but this is a very complicated thing. It's another beast. But normally, and all setups I've seen in the wild is that you simply secure it with user and password, and your Nagios user then is available and has all the full power of JMX, for example, to stop this whole server. This is really something not very nice. Okay, now let's just have a short overview over the architecture. You have this JVM. Within the JVM, you have the JMX subsystem. And within the JMX subsystem, you have an ambient server, which is the central entity and which serves as a kind of registry for your ambients, which is another entity. And the ambients themselves expose certain metrics which you can read with get and set, or certain operations for management for execution. And these ambients came from various sources. One of them is directly from the VM. So if you start the JVM, you have already a whole set of ambients available, like heap memory or thread statistics. But then there's also the application instrumentation, where your application server exposes certain metrics like HTTP traffic or database connection pools. And even more, you on your own can write your own ambients and register at the ambient server. If it is registered, then it's available within the JVM quite easily. It's a simple Java call. But if you want to export it, you need to use an JSR 160 connector, which by default, there's only one connector available. It's the RMI connector. The other ones which you can see are the JMX-MP. It's a JMX messaging protocol. It's optional. But in practice, you only have this RMI connector with all his problems. And if you're then out of the JVM, you can access JMX with the JSR 160 client. One prominent example here is the Java JConsole. And yes, and this is a situation what we had before. I'm trying really to set up some Nagios monitoring, and I came up with some sort of solution which is really quite easy and normally quite trivial. It's an agent-based approach where you install an agent within the JVM, which can access the ambient server locally, which is, as I said, quite easy, and exports all this information via HTTP and JSON. And on top of that, this HTTP and JSON protocol obviously opens up a whole new world of possible clients. So any client who speaks HTTP and JSON, and every language out there has support for this, can now access JMX. Yes, and one prominent client here is Hot.io. It's an HTML5 console, which I'm talking about in some seconds. Okay, what kind of agents are available? There's one very trivial one. It's a JE agent. It's a normal WAR file, which you simply deploy and put into the JE server in a servlet container. And it exports all the information of the usual HTTP connector of the servlet container. Then there is an OSGI bundle, which you can use and install. This OSGI bundle uses the OSGI HTTP service for exporting this information. There's a special agent for Mule, which Mule itself has an own management API which can be used there. And then there's a Swiss Army knife agent, I call it. It's a JVM agent which you can use directly as a Java agent with every Java process. It uses a Java attach API, and we will see a demo soon about this one. Okay, here's a short list about all the products which uses Jolokia. Jolokia itself is now 4 years old, and one of the prominent ones is Hot.io. It's an AngularJS-based HTML5 console, and if you never tried it yet, I highly recommend to try this one out, because it has tons of plugins for various backend systems. You can visualize your camel routes and so forth. So it's really a cool thing, and this console talks via JavaScript, AngularJS directly to the agent. Then ActiveMQ, since version 5.9, uses Jolokia as its official REST management API. So everything which I'm telling you today, you can directly use with ActiveMQ. Then there's Fabricate. I don't know whether you know about or have ever heard about Fabricate. It's a quite new thingy. It's a part of JBoss Fuse. and it's called an open source integration platform. And here, Jolokia plays also the role as a connection between the admin UI and the backend. And finally, there are some Spring projects which directly use Jolokia. Spring Boot, if you put Jolokia into the class path, you automatically get all the benefits I'm just showing you now. Okay, what kind of request file is supported by Jolokia? You can read attributes, you can write attributes, you can execute operations, you can search for ambients. These are these entities which are registered at the ambient server. You can list some metadata, and of course you can get the version of the agent itself and about its environment. What is missing here are notifications for the moment. Notifications are not yet supported, but I will show you something which, but it's on the roadmap for Jolokia 2.0, and I have a small demonstration what we have here. Okay, now it's time for some demo. So what I'm going to show you now is, first of all, the installation of this Java. So I have to, of course, if I need the mouse, I should plug it in. The installation of the agent itself, what I have here in this directory, can you see it? Okay. There's a plain Apache freshly downloaded from Apache Tomcat. So I just extract that one. Then I start it, as I do. So nothing special. So it's really fresh out of the archive. And now I have this Jolokia jar. This you can also do. Oops, I have to go up one. This agent, which is around 400 kilobyte large. You can download it from Maven Central. It's there. It's in version 1.2.3. You can download it directly from jolokia.org. Or you can use some tools which from JMX for Perl, which can download it for you automatically. So now let's start that one. So if I'm calling this, you see it's the same output as JPS, so it lists all Java processes actually running on the machine. You see here two Bootstrap, which is the Tomcat. There's a second Tomcat for the Jolokia.0 demo, so what I'm taking now is the oldest one. And I'd simply add here the PID. You can, if you can also add a pattern. So if you have a unique pattern, you can simply say Bootstrap if you have only one Tomcat, and it would connect to this process. And if I open now this idea and go here, you get I can make it a little bit smaller, I think. You get the metadata of the agent itself. So you see the version number, but you see also what kind of server it is running. So it has some detection facilities to detect the server itself. And if you want to make a JMX request, you can do it in two ways. One, either with a post request or with a GET request. In this example here, I'm using a GET request, which is simply the type. I want to read something. I have the MB name and I have the attribute name, which I want to read. And if I send it, I get back a JSON response with a timestamp, a status, the request repeated. And this here, it's a JSON structure, and then the value, which for the heap memory usage, it's a composite data on the server side, and this is automatically serialized in some JSON structure. So Jolokia knows how to serialize any Java object, and here you see you have a use pattern. Okay. Now let's write a little JavaScript client. What I have, so I'm a little bit late of time, so I'm just starting with the first version, debug, okay. Okay, what you see here, I'm explaining everything here. Okay, first of all, you need to create an agent object, and you see this is directly the port which I have from the agent URL, and then you can use some methods to obtain certain metrics. You have to include the JSON, Jolokia.js. And then with get attribute, you can simply enter the MB name, the attribute name, and then a so-called path attribute, which simply dives into this complex data structure which you have. And finally, then there's simply some jQuery expression to update this paragraph which you see here, and on the right side you see directly that in that case there are 45 megabyte. Now let's add some garbage collection to this one. So it's the same code here, but I have also here some button which when clicked will call the GC function, and again it's the same Jolokia agent object. You call execute in that case in order to execute a JMX operation, MB name, operation name, and afterwards you make an update in order to update the heap memory again. And if I do that one, oops, then you see that the memory itself, it drops down. Okay, let's go on. Next step is to make this periodically, so that you simply request this value every certain time, every second maybe. And this Jolokia client library also has a scheduler included. And in that case I have, okay, let me explain that one. I have again this Jolokia agent. I have a function, you see it's the same as before. And what you see here now is that I have the request. The request is this JSON structure which is can directly be interpreted by the agent. As the request has a type, has the MB name attribute. If I would like to call an operation, I would have here, operation could put in arguments. All this, the syntax of this request is very well explained in the reference manual. And what I do next is that I use a method called register, where I register this request to this Jolokia agent with a callback function, which is called every time when the response comes back. And afterwards, I start this scheduler. So in that case, every 100 milliseconds, I'm sending a request and get back the answer. And again, the garbage collection, you see that the memory counts up because for the operation of the Jolokia agent, you need some temporary heap memory, which of course is being cleaned up, and you end up at the same baseline if you do the garbage collection. Okay, finally, now let's add some charts. What I'm doing here now is I'm adding a chart library called Float. It's a jQuery plugin. It's a very simple library which can be customized, but in that case I have simply plain used it in a plain mode. And here I again have the agent. I have the garbage collection operation as before. I have the request. Then I have here a data object. It's simply in JavaScript array. Then I register again a job. I have still this update of the label here with the memory. But then I simply push from the response the timestamp. You have seen in the browser that there's always a timestamp included in the response, and the value. And though we have this tuple which you push on the data, and the next step is simply specific for JFlot, where you update the chart diff in that case. And the request at the end, that's all. And then the scheduler, and if I make now here a garbage collection, you can easily see that it drops down and starts again. Of course, in a production code, one would do it a little bit more intelligently, so you have to clean up this data, of course, shift out the old data, and as you can see, the chart in that example really squeezes over time, and normally you would have it to move along. Okay, but I think it's a good example how easy you can access the agent and write your own JavaScript, and this sort of graphs wouldn't be possible directly with JS 160 because the browser itself only speaks JavaScript, and you need some solution like that one. Okay, to the slides I have some. Okay, what else? What can Jolokia do for you? There are some stuff which is not available in JMX itself or JS160. One of them are so-called bulk requests. Bulk requests are a very simple concept. It's simply an array of JSON objects as requests which are sent as a whole to the agent. The agent locally dispatches each request, resulting in a local JMX call, collects all the responses, and sends back a JSON array with all the responses. And so you need to have only one HTTP round trip for a whole bunch of requests. And this is very suitable, very helpful, for example, if you really do Nagios monitoring, where you typically have 20 to 30 different kind of metrics which you want to monitor, but you only need one single HTTP request for that. That's quite nice. Another thing is that so-called JS160 proxy. This is useful in situations where you cannot install an agent. The agent is a sort of software, and sometimes there are mostly political reasons why you can't install some extra software on the holy JEE server. Or another reason might be that you already everything have prepared for JS160 and you don't want to add an extra path. Though this JS160 proxy isn't dedicated Tomcat or Jetty, a very slim servlet which you can choose on your own. You deploy the agent on that one, and the agent itself gets the request, and the request is some sort of parameter which tells the agent, okay, don't measure the MBean on my host, but forward it to the via JS160 to the target host, calls the target server, collects via JS160 the response, and converts it back to a JSON response to the original requester. With this, the advantage of this setup is that you can cross firewall boundaries very easily, and you save the startup costs of the JVM if you do this multiple times, because the proxy is always running. Then Jolokia knows about so-called fine-grained security via XML policies. There's a sort of XML file where you really can restrict upon the IP, so which IP can connect, which subnet, which operations are allowed, can I only read or can I execute something, you can provide ambience patterns and so forth. And so you have a very powerful mechanism to restrict the access to the ambience, to the JMX subsystem. Then there's some tooling with JMX for Perl, and a whole bunch of client libraries. One of them was this JavaScript library, which I just have shown, but there's also a Java library itself, a Perl library, and also Python, Node, and so on. So, but writing an own client binding is not really hard because everything is documented from the protocol, and it's quite easy. Okay, now some sneak preview to the next version, Jolokia 2.0. What's next? As I said, Jolokia doesn't support yet notifications, so this is on the list. And we have an initial implementation which uses polling. I'm just showing you a demo how this works. But beside polling of course is not really the perfect solution. We are targeting for one of the next releases then using really WebSockets or server-side events when they are available, or even things like JMS. Then on the roadmap is role-based security. I just told you that there's a fine-grained security policy, but it's only for one user. So it's the same as for JMX. For JS160, you connect with a user and a password, and then you have this restriction, of course, but it's the same for every user with the same password. And role-based security, of course, makes much sense because you typically have a monitoring user. Your Nagios user only should read attributes, but you also have this sort of admin consoles like Hot.io and other stuff which really want to manage these things. So you want to separate monitoring and management. Then, finally, there's some modularization on the way, which really abstracts the backend, so you can then exchange this JMX backend and can plug in or use a different one like a Spring backend. So in that case, you can use the same protocol for accessing, for example, Spring Bean information in a Spring application context, or Zookeeper or Chain. So everything which you can, where you can read and write or execute something on, could be in principle exchanged. The first and default implementation is of course is still JMX. Then you can exchange the JSON serializer or even the security mechanism, which you how to restrict the access. Okay, Now let's, oops, going in the wrong direction. No problem, because at the demo anyway. So let me go to my. So I have here now. So first of all, let's close that one. Start that one. Okay, what do I have here now? Before I show you the JavaScript code, okay, I'm here. I just want to say what's needed on the server side. On the server side, you have. I make it a little larger. You need to add an ambient. So what I'm doing, okay, sorry, I forgot. What I'm going to show you now is the notorious chat example, which you always see if some sort of notification push thing is going on. So what I'm doing now is I'm writing an ambient, which is quite simple. I don't go into much detail here because there's not much time for that. But what I do here is to write a standard ambient. So you can see it from the interface, which is also has some extension JMX standard class notification broadcaster support in order to broadcast notifications to other to listeners. Then in the constructor itself, it calls a super constructor, which is some extra metadata. And one and single operation which is exposed by this ambient is called message. This message takes a user and a message, constructs a notification object. This is the standard JMX way how to throw notifications events via JMX. Construct some user-specific data. Here it's a user, and the message is put into a map, and this map is set into the notification itself, and then the notification is sent out. This ambient you need to register in the ambient server. In this example, it's done via Servlet, which is deployed on Tomcat, and it does not much more than in the init method simply gets the ambient server which I have shown and register this ambient here with a specific name. This object name is unique within the ambient server, and you can now access this ambient from the outside. And how this is done is shown next. So I have here again my JavaScript client. I create this Jolokia thingy. Then I register here for notification. You see that I can register for notification from the client side for a certain ambient and can provide a callback method, which is a function which is called anytime a notification arrives. And for each notification, simply the message is appended here at this table below. And the second part is that how to send a message is simply a listener on this text input box, which on return execute a JMX operation exactly on this ambient, very ambient, with the message operation, and as arguments I provide the user and the message as arguments coming from the input fields. Okay, and afterwards I clear that one. So now to see what's happening, I'm just opening. Okay, I have two. Doesn't matter. So now let's say. And you see that it directly gets transported to the other clients. Yeah. And finally, the good thing is here that you can use any JMX client to produce a message. I have, for example, here one which uses the so-called J4P SH. There's a tool. It's a command line shell for accessing Jolokia. And if I provide here so I'm just it up. So you can traverse the JMX namespace like in the shell. So you go into this devox directory, then you go into the ambient called chat, and then you can call with exec. You can call the message and say, okay, it's coming from J4P, and then also hello. And you see that it also arrives at the same JavaScript client. Okay. Yeah, so this is everything I have to show for you. So Jolokia 2.0, probably at the beginning of next year, will be released. And I have 1 minute left for questions. So are there any questions somewhere? Okay, so thank you very much, and I wish you a nice evening.
The Tennessee stud was long and lean, the color of the sun, and his eyes were green. He had the nerve and he had the blood. There never was a horse like the Tennessee stud.